Alright, so here's the VBA portion of our spreadsheet. So we have our PDF here. We have some outputs I'm going to describe and some inputs I'm going to describe. So the first question is, which is location is the highest probability of being late? And if we look at Sydney, Australia, we're saying that the delivery guarantee is 15 days. It takes 8 days, 3 plus 5, to get to the customer from New York City, which is added onto this. And we look at here, so that means that any day 8 or over for the transit time is gonna result in a late delivery. And we look at this, and there's a 90% chance that any delivery from Australia is going to be late. So that'd be the answer to that question, which is interesting. That 90% of orders from Australia are not going to meet our guarantee to the customer. So let's take a look at the VBA code here. Starting off with our variables, we got order location, which is going to specify which of these 5 our order is coming from. Transit time, which is gonna specify where in this PDF from our order location is our transit time gonna lie. Late products, which is gonna shoot out here in our number of late orders that we have. Our max late is the maximum days late among all orders, so it looks at which order was latest and how many days late it was out of all 10,000 in our simulation. I, J, K, and M are all going to be counters. PDF day is going to be a counter too for the PDF. We got the transit probability, which is going to help us select from this PDF. Our late per city, which is the total days late by city. That's an array that's going to shoot out here. NY to DC, DC to customer, and guarantee are all input variables here. And then total days is going to be something that we use to calculate the days late per iteration in the simulation. And then orders by day, something that shoots out here, and it's going to be reflected in our bar chart, which is kind of just a distribution of like, okay, how many days is it going to take to get a MIC, like in a distribution from our, or to get to MIC from our sources. So first thing in the code is in specifying, okay, here's our input for our delivery guarantee, our transit time from NYC to DC, and our transit time from DC to customer. And these can be specified by the user as these change. And then starting with a I equal to 0, and our do loop, well, I is less than 10,000, so that means we're going to do it 10,000 times, because at the end here we have I equals I plus 1. So it's going to go through this 10,000 times and spit out our result. So it starts off by finding our transit probability, which is a random number between 0 and 1 times 100, so it's a random number between 0 and 100. And then our order location, which is a random integer between 1 and 5, so that selects from this like 1, 2, 3, 4, 5. So these are our 5 here. And then we're looking at, going through the PDF for each one from 2 to 12. We're looking at, okay, so we have this transition probability, a random number between 1 and 100. And it's looking at the sum up to that point, and whenever it crosses over that number, it records this number of days as our transit time. So say this number is like 21, this transit probability. So it's not here because this is 10, not here because this is 20, but here it's 30, now it's greater than our 21. So it's going to record 4 as our PDF days. Our transit time becomes that number, and then it adds to our orders by day count down here each time. So these numbers will all total 10,000. This is the number of orders kind of distributed by the day of the amount of time it takes to get from our source to New York City. And then it's going to keep going through that, but once it finds it, it gets out of that for loop that's doing. So it only records it once. And then from there it calculates, okay, based on this, what's our total days of delivery? So we have, say it was 4 plus 3 plus 5 is 12 would be our total days. And then for anything over 7, we're going to have total days greater than guarantee. And that's going to mean that the product's late, so it takes the late products count and adds 1 to it. And that's this result here. So every time it's late, it adds 1 to that. If not, it doesn't add anything to it. And then if our total days minus our guarantee is greater than the maximum days late that we've already recorded, then the maximum days late is going to equal that number of days late that we have. So in our simulation it's going to be 5 just about every time because of the number of iterations we're doing. But say we were to do 20, there'd be a chance of there being 4 or 3. But because there's so many, then there's going to be at least one, pretty much that has a 12-day time to go from the source to NYC. So 12 plus 3 plus 5 is 20, minus 15 is 5. And then we're looking at finding our total days late per city. So if our order location is here, then our total days is greater than our guarantee, then that late per city, it's going to find out the number of days late and then add it to this count in this array. So that's just keeping a running count of like, okay, how many days late total do we have by location? And then we're looking at, and then that all sums up to our total days late here. And then that's all the recording of the variables through that loop, and it does it 10,000 times for each order in our simulation. And then we're going and we're putting that into the sheet here. So this is our max days late, which comes right here. Our late products, which comes right here. Our late per city is going to come right here. And then our orders by day is going to come here, so we can look at the distribution of orders. And it's going to update our bar chart when we're done, and sort of update all these numbers. So I'm gonna run it once, so we can kind of look at what happens. So I run it a few times. So you see these numbers change a lot, but because it's so many orders, it looks really similar, and the distribution is pretty similar. It kind of levels out as to what you would expect over time. So since we're doing so many, we can really kind of almost predict how this is actually going to happen, what it's actually going to look like. And we see that, like, a lot of these orders are going to be late, which is interesting. Maybe we need to change our guarantee, or look at trying to find a more expensive but faster way to get our products to NYC and from there to the customer in a shorter amount of time, so we can keep this guarantee and maintain customer relations. It's really great just doing so many simulations. We don't have to actually do anything, but we can look at, based on our probabilities, what our order distribution and what our orders over a quarter or whatever would look like, based off these assumptions that we make. And it's just really a really powerful tool to really predict, that wow, okay, maybe we need to make some changes. But also, like, we have some a picture of what our order distribution is going to look like over a long period of time.